Our chi-square test gives us our data in a slightly different manner than what we have previously been used to. Instead of just giving the straight up data, we're given a two-way table where we can calculate proportions of the whole, or can look at just the number that fall in each category, basically. So we're looking at an addiction to cocaine example here. And basically they're trying different treatments to see what is the best treatment that will defer another relapse. So one of the things with cocaine is that when people take cocaine, they fall off, they take the drug, they get on a really high, and then as soon as it's done, they fall off and are on a really low. So research wanted to test to see if an antidepressant may also be as good, if not better, than the standard treatment. So the research decided to test the standard treatment of lithium, the antidepressant desipramine, and a placebo. So when we do a chi-square test, all we're trying to determine is there a difference among the proportions. We're not trying to figure out which one's greater than or less than another one. We're just testing the different proportions. And then if we do find a difference, then we'll go through and we'll do a two proportion test to determine which ones are actually greater. So looking at this, our null hypothesis is just that all the proportions are equal. The proportions that did not relapse for lithium are the same that did not relapse for desipramine, and so on. Our alternative is that all these proportions are not equal. So let's go ahead and go to StatCrunch, and if you do not have this typed in, go ahead and pause the video and type in the two-way table now. To do the two-way table and to do a chi-squared, we're going to have to go a slightly different route. It's not as obvious as our other testing has been in StatCrunch. So you will end up going to Stat, Tables, and it's going to be the contingency table, and it's with summary because this is the summarized data. It's not the actual counts or anything like that, or the actual data, each individual case and so on. It's the summarized because it's a two-way table. Our counts our columns are the no relapse and the relapse. Our row is the drug. Okay, so we're dividing it up by no relapse and relapse according to drug. You will want your expected counts and your chi-squared contributions. Both of those values are extremely important. Okay. We want to make sure we're doing the chi-squared test for independence. We can leave the 95% confidence interval. That is fine with me. And then click Calculate. This is our chi-squared printout. Now, the chi-squared printout has a lot of information in it, and it's important that you understand what this information is giving you. It takes your two-way table and it divides it up, and we're looking to see where the highest chi-squared contributions occur. In this instance, as you can see the cell format, the contributions to chi-square are the very last value. So those are those last ones in parentheses there. Okay. Our largest values there lie, I would say, between the desipramine no relapse and the desipramine relapse. You could also look at the placebo and the desipramine, or the desipramine looks to be possibly higher, obviously higher than the lithium, that type of thing. So obviously this is our area where our highest differences occur, and then we can go from there to determine what those differences are. And that's what our chi-squared contribution tells us. If we look, our p-value is very low, so that tells me I can reject my null and accept my alternative, that yes, there is a difference in the proportions. And our chi-squared value right here, 15.22, that is a fairly high value considering the data set we have. So high chi-squared should support a low p-value. So now we can take our chi-squared and we can break it down into further testing, which I will do here on the following slide.